Chapter 3, Section 4 is perpendicular lines. Now, we have one definition and three theorems. The first definition is perpendicular bisector. And what a perpendicular bisector is, it's the line that is perpendicular to a segment at the segment's midpoint. Now, it doesn't have to just be a line. It could be a ray, it could be another segment, it could also be another plane. All it has to be is perpendicular to the segment and go through the segment's midpoint. So, line AC here is a perpendicular bisector of BD because it forms a 90-degree angle, so it's perpendicular, and it goes to the midpoint C. And C is midpoint because BC is 8.78 and CD is 8.78. So line AC would be the perpendicular bisector of line segment BD. Okay, now perpendicular lines are also used to show distance. So when I have a point A and I wanted the distance from A to DE, well, the distance is a perpendicular line from A to that segment. So in this case, A to DE. Now, this angle is ABE. It's 90 degrees, so therefore it's perpendicular. And it is the shortest distance. A to B is 4.28. If you notice, when I have AC here, when I move it back and forth, it is always bigger than AB, unless it is actually at AB, where it is 4.28. Okay? So this line would always be larger than the perpendicular one. Now it looks like a bisector, but I don't know that for sure, and it doesn't have to be in order to be the distance. So a perpendicular bisector can be the distance to a line from a point, but a distance doesn't always have to split it at the midpoint. Okay? So let's say, for example, that instead of actually having numbers here, I labeled this as x plus 2. That's the distance of AB. And this is 15. That's the distance of AC. Now, since I know that AB is perpendicular by the 90-degree angle here, that means that this is the shortest distance from A to DE. So that means that x plus 2 has to be less than 15. So I could write 15 is greater than x plus 2. And now I could solve for all the x values that make this a true statement. So as long as x is less than 13, AB is a possible distance. Okay, so that could be like 5, 6, 7, any one of those. It makes AB true. Okay. All right, first theorem we have: if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So what does that mean? That's saying if angle 1 and angle 2 here are congruent, and they are a linear pair, then that means that the two lines intersecting are perpendicular. Well, 90 degrees, 90 degrees, so therefore they are congruent, and when it's equal to 90, that means they are perpendicular. So that's the theorem. Two intersecting lines that have a linear pair, so 1 and 2 are a linear pair, and they are congruent, then the lines are perpendicular. Alright, second theorem, perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of the planes, then it is perpendicular to the other line. So I have J here. It's a transversal for K and L, and it is 90 degrees here. Okay. K and L are parallel. So if K and L are parallel, that means that this angle here is also 90 degrees. Because if they're parallel, corresponding angles are supposed to be congruent. So if this one is perpendicular at 90 degrees, that means this one also is perpendicular at 90 degrees. Okay, the third theorem is if two coplanar lines are perpendicular to the same line, so this line J is perpendicular to L, and this line K is also perpendicular to L. Since they are both perpendicular, then these two lines, J and K, are parallel. So two lines perpendicular to the same line means that those two lines are parallel. Okay, so you have a perpendicular bisector and our three theorems. Right, that wraps it up for Chapter 3, Section 4.